Every single time you type a prompt into a generative AI tool or, ask it to create an image, you're setting off this massive physical chain reaction.
Yeah, a lot of people don't realize the sheer scale of it.
Right. Because generating just one AI image uses roughly the same amount of electricity as fully charging your smartphone.
Which is wild when you think about it.
It's crazy. Now, multiply that by hundreds of millions of users
Hmm.
running billions of queries like all day, every day.
The scale gets incomprehensible very quickly.
Exactly. Suddenly, the cloud doesn't look like a fluffy cloud at all. I mean, it looks like a massive,
Yeah.
incredibly resource-hungry industrial machine.
That is a very good way to put it.
Well, welcome to today's deep dive. Our mission today is to explore a single, incredibly timely source document that reveals how this sudden boom in artificial intelligence is, well, it's completely rewiring our global clean energy transition.
Yeah, and it's doing it at breakneck speed.
Right. This is about the heavy physical reality of the electricity powering our future.
Okay, let's unpack this because the old narrative we've been fed for years was beautifully simple, right? Just build more wind and solar, slowly retire the coal plants, and step by step, the grid gets green.
Right, that was the comfort zone.
But according to our sources, AI is exposing that story as, frankly, dramatically incomplete.
Yeah, what's fascinating here is the core timing mismatch that the AI boom has created. We are dealing with two very different clocks ticking simultaneously.
Like two different realities of speed.
Exactly. The AI industry is driven by rapid technological iteration. I mean, they need massive amounts of power, and they need it connected right now.
Right, I can't wait.
No, they can't. Conversely, the ideal low-carbon solutions,
Yeah.
Vast new transmission lines to carry distant wind power or advanced nuclear reactors, those operate on a multi-year, often multi-decade timeline.
So we have demand that operates in months, colliding with an infrastructure that operates in decades.
That's the core tension, yes.
Yes.
But let's ground this for the listener. What does an AI data center actually demand from the grid? I mean, when I hear data center, my brain just defaults to a really big, really cold office building filled with servers.
Right, sure.
But our source makes it clear this is not just another office park.
No, not at all. The term the industry uses is hyperscale.
Hyperscale.
Yeah, and a hyperscale data center is this massive facility engineered to house tens of thousands of servers. And the scale of power they draw is just staggering.
How staggering are we talking?
Well, a single campus today can require hundreds of megawatts. And when tech companies cluster these campuses together to train their most advanced AI models,
Oh, wow.
the demand pushes into gigawatt territory.
A gigawatt.
Yeah. To give you a sense of scale, a single gigawatt is roughly the entire output of a large-scale nuclear reactor.
Wait, just to power one localized cluster of computers?
Exactly. One cluster.
I'm trying to wrap my head around that.
Right.
1 gigawatt for a single cluster. But it isn't just the sheer volume of power, is it?
No, it's...
Because the source emphasizes that these facilities demand firm power. What does that actually mean in practice?
So firm power means electricity that is available on demand 24 hours a day, 7 days a week, regardless of the weather, regardless of the time of day.
So it can never dip.
Never. AI loads are completely inflexible. The specialized processors they use generate immense heat, which means they require massive, continuous cooling systems.
Oh, right, because if they overheat, everything shuts down.
Right. They cannot tolerate instability on the grid, a dip in voltage or, a temporary interruption.
Even for a second.
Even a blip can corrupt weeks of machine learning training. They require a constant, flawless stream of electricity.
Okay, let me try an analogy here to see if I'm grasping the shift. The traditional power grid we've lived with for decades seems a bit like a city bus system.
Okay, a bus system.
Yeah, like you have rush hours in the morning when everyone wakes up, makes coffee, turns on the heat. Then you have quiet times in the middle of the night.
Sure, peak and off-peak.
Right, and grid operators are used to that ebb and flow. They know how to manage the peaks and valleys. But an AI gigawatt cluster that feels more like a massive, heavily loaded freight train.
Oh, that's a great way to look at it.
Because it never slows down, it never stops at a station, and it requires the tracks to be flawlessly clear around the clock.
Yes, and the freight train analogy highlights exactly why the old corporate sustainability models are collapsing.
Wait, collapsing? How so?
Well, For the past decade, corporate decarbonization relied heavily on an accounting mechanism called annual matching.
Using renewable energy certificates, right? RECs.
Exactly, RECs. A company could run its data centers on fossil fuels during the night, buy excess solar credits generated by a farm hundreds of miles away during the day.
And just claim their operations were 100% green on paper.
Precisely. On paper.
Hold on. I always thought RECs meant a company was actually running its operations directly on green energy. You say it was largely an accounting exercise?
For many companies, yes, it was entirely a ledger balancing act.
That's wow.
But a paper certificate cannot power a massive cooling system at 2 in the morning when the wind isn't blowing.
Obviously.
Right. So the utility serving that data center is physically forced to deliver actual electrons locally in real time.
Because of this unrelenting freight train of demand.
Exactly. Utilities are having to completely rethink their generation plans and their long-term infrastructure.
Because the old way doesn't work for AI.
Right. Having wind and solar as a backbone is highly effective for reducing overall grid emissions, but it is no longer sufficient on its own to guarantee firm power for these hyper-reliable needs.
Okay, so if wind and solar are inherently intermittent, the sun sets, the wind dies down. How is the market actually filling that massive gap for AI right now?
Well,
Because I know the immediate reaction from a lot of people listening is probably just build giant batteries.
yeah, and storage is a crucial piece of the puzzle, definitely. But current commercial battery deployments have strict limitations.
Like what?
The vast majority of utility-scale batteries being installed today are lithium-ion systems designed for short-duration balancing.
Meaning they don't last very long.
Right. They typically discharge for about 4 hours.
4 hours, that's it.
That's the standard right now. They are excellent for smoothing out the sudden drop in power when a cloud covers a solar farm, or shifting afternoon solar power into the early evening peak.
Right, taking the edge off.
But they cannot carry a gigawatt-scale data center through a multi-day winter storm where renewable generation drops to near zero.
And we're talking about data centers filled with specialized GPUs that represent billions of dollars of capital just sitting in a room.
Exactly.
You can't just have a $2 billion building sitting idle, waiting for a multi-day weather event to pass, or waiting for a new transmission line to be built in 2032.
You really can't. The financial carrying cost of that idle hardware dictates everything. In this environment, speed is the ultimate strategic variable. Yes. And because developers cannot afford to wait years for grid expansions, natural gas is returning to the conversation as the default bridge technology.
Wait, okay. I have to push back here.
Go ahead.
We are building the hyper-advanced, futuristic AI economy on natural gas.
I know, it sounds counterintuitive.
The fossil fuel we spent the last decade trying to phase out of the power sector. How does that possibly fit into all those net zero climate pledges these big tech companies heavily advertise?
Well, the friction between those corporate climate narratives and the physical reality of grid execution is severe.
I mean, I would imagine so.
But markets, however, do not reward ideological comfort. They reward execution.
Wow. Okay.
And gas turbines offer 3 distinct advantages in this high-pressure environment. First, they are dispatchable.
Meaning you can just turn them on when you need them.
Exactly. Operators can turn them on and ramp them up exactly when the demand hits. Second, they are a known entity to grid operators who need to guarantee stability.
They're comfortable with it.
Right. And finally, and perhaps most importantly, they are deeply familiar to the financial sector.
The bank.
The banks. They know exactly how to assess the risk of a gas plant, and they are comparatively fast to deploy.
So it sounds like gas isn't winning because it's an elegant solution for the future, but simply because it is available, it works right now, and the banks will fund it.
Yeah, it is a purely pragmatic choice driven by the ticking clock of AI deployment. Companies need firm power today, not a decade from now.
But nobody wants to rely on a high-emission bridge forever.
No, absolutely not.
So we naturally have to look at the ultimate low-carbon, high-reliability solution, which is nuclear power. And here's where it gets really interesting.
It really does.
Because for years, the nuclear industry has been effectively stalled. Everyone agreed advanced nuclear and small modular reactors, SMRs, held incredible promise. But no one could secure the funding to actually build the first commercial fleets.
It was always 10 years away.
Right. But now we are seeing major tech companies stepping in to directly back these nuclear developers.
Yes, and big tech's entrance into the nuclear space solves a historical, existential problem for the industry.
Which is what?
The credibility of future demand. For decades, nuclear developers struggled to secure financing because of the massive upfront capital required.
Because it's billions of dollars.
Exactly, and the uncertainty of who would actually buy the power 20 years down the line.
I want to try an analogy to explain why big tech is the missing puzzle piece here.
Let's hear it.
So building a new nuclear plant is like developing a massive, incredibly expensive new shopping mall.
Okay.
For years, the developers were going to the banks saying, if you loan us the billions to build this mall, we promise people will want to rent the stores.
And the bank said no?
Right. The banks
Yeah.
looked at the risk and said no. But big tech is stepping in as the anchor tenant. They are the giant department store that signs an ironclad 20-year lease before a single shovel even hits the dirt.
That's a perfect analogy.
Once the bank sees that guaranteed buyer with incredibly deep pockets, the entire project becomes bankable.
Exactly. The anchor-tenant dynamic is fundamentally shifting advanced nuclear from a theoretical talking point into a commercially viable pathway.
Because the tech companies have the money.
Right. Hyperscalers possess the massive balance sheets required to absorb those initial financial risks. However,
There's a catch.
there is. The source material emphasizes a hard reality check. Advanced nuclear does not solve the immediate crunch.
Because even with the money secured, the clock is still ticking. You still have to build the things.
And that takes time. Most of these small modular reactor projects are in the early stages of design and regulatory approval.
So they aren't going to be ready tomorrow.
No, they are not going to meet the urgent wave of data center expansion happening over the next 3 to 5 years.
Right.
The industry still has to navigate a labyrinth of licensing, immature supply chains, the inherent risks of mega construction, and severe workforce constraints.
Which exposes the unglamorous underbelly of this entire technological revolution. The source calls this bottleneck management.
Bottleneck management.
Yeah, it turns out, even if you have billions of dollars and you get the green light for the gas plant or the solar farm or the nuclear reactor, you slam straight into the physical limits of the existing world.
Yeah, if we connect this to the bigger picture, the entire decarbonization narrative is shifting.
Shifting how?
Well, for the last 10 years, the focus was almost entirely on the cost curve of technology, celebrating how cheap solar panels and wind turbines are getting.
Right, the prices kept dropping.
Exactly. But today, the real game is navigating physical and bureaucratic bottlenecks. Take interconnection queues, for example.
Now, I hear that phrase, interconnection queues, thrown around by energy analysts all the time. What does it actually mean? Is it just a wait list, like taking a number at the DMV?
I mean, I wish it were that simple. It is significantly more complex than a simple wait list.
Okay.
When a developer wants to connect a new power plant to the grid, they can't just plug it in. The electrical grid is a delicately balanced machine.
You can't just snap it together like Legos.
Right. The utility operator has to conduct a rigorous multi-year engineering study to ensure that adding a new gigawatt of power won't overload existing lines or cause cascading failures.
Oh, because if it overloads, the whole system goes down.
Exactly. And because of the massive influx of renewable projects and new loads, these study queues are severely backlogged.
Backlog.
Projects are sitting in regulatory limbo for 3, sometimes 5 years, just waiting for permission to connect.
Wow. And it gets even more granular than that. The source points out that we are facing a global transformer shortage.
Yes.
Literally, the metal boxes sitting at electrical substations are now a strategic constraint for the future of AI. Why can't we just build more of them?
Because it's not that easy. Transformers are critical. They step the extremely high voltage from transmission lines down to a level that a data center or a local neighborhood can actually use.
No, they're the middlemen.
Exactly. You cannot build or upgrade a grid without them. But the manufacturing process requires a highly specialized material called grain-oriented electrical steel.
Grain-oriented electrical steel.
Yeah, and there are only a handful of facilities globally that produce it to the required standard.
Oh, so it's a bottleneck at the raw material level.
Precisely. Because of the sudden spike in global grid upgrades, the supply chain is overwhelmed. Lead times for large power transformers have stretched from roughly a year to sometimes 3 or 4 years.
So you could have your data center built, your power source approved, and you were just sitting around for 3 years waiting for a metal box to step down the voltage.
Pretty much.
That is wild. The source also mentions water and labor as massive hurdles.
Yeah, they are. Cooling these hyperscale data centers requires millions of gallons of water.
Which people are starting to notice.
Yes, this is becoming a highly visible and contentious public issue, particularly in regions already facing drought stress.
Right?
Furthermore, the labor pool is finite. Data centers, gas plants, transmission line upgrades, and nuclear projects all draw from overlapping pools of highly skilled workers.
So they're all poaching from each other.
Exactly. They are all fiercely competing for the same specialized electricians, pipe fitters, and power engineers.
This sounds like a multi-dimensional chess game where money alone isn't enough to win.
No, it's not.
Whoever can solve for speed, supply chains, grid readiness, and local permitting all at exactly the same time is going to dominate,
Absolutely.
which completely reshapes corporate credibility in the business world. With all these physical bottlenecks exposed, the era of slick, marketing-driven, ESG, environmental, social, and governance reports seems effectively over.
It really does. The level of scrutiny has intensified dramatically.
People are paying closer attention.
They are. Investors, local regulators, and host communities are no longer satisfied with broad sustainability claims backed by those paper certificates we discussed earlier.
They want the receipts.
They are asking hard physical questions. If a tech company is visibly building a massive physical load that requires firm electricity in a community's backyard, local residents want to know, where is the actual power coming from?
Right. Are local emissions going up because a dormant gas plant had to be turned back on to support it?
Exactly. That's a huge concern.
And I imagine they are asking, who is paying for all the grid upgrades required to support that data center?
Oh, that is becoming one of the most contentious regulatory battles right now.
I bet.
Because if a utility has to spend $1 billion upgrading transmission lines and substations primarily to serve a single tech company's data center, who foots the bill?
Right. Does the tech company pay or do I pay?
Well, if the utility socializes that cost, meaning they spread it out among all their residential customers, you suddenly have everyday citizens subsidizing the infrastructure for a multi-trillion-dollar corporation.
Oh, that is going to make people very angry.
Right, and regulators are starting to aggressively scrutinize those cost-sharing arrangements.
It totally changes the definition of going green. It's no longer just an accounting exercise. It is a hard-nosed commercial, political, and permitting battle.
It is a physical battle now.
So let's look at the actual companies involved here. Who actually profits from this chaos and who gets crushed? Let's start with the winners in this new paradigm.
Well, the near-term winners are the entities that can deliver execution and reliability.
The people who can build things fast.
Yes. Gas turbine manufacturers and flexible gas plant developers are clear, immediate beneficiaries.
Makes sense.
Also, the companies manufacturing grid equipment, specifically those producing the highly sought-after transformers, are seeing unprecedented demand.
Because everyone needs those metal boxes.
Exactly. And utilities operating in regions with heavy data center growth will experience massive revenue increases, assuming they can navigate the regulatory scrutiny over who pays for upgrades.
Okay, what about on the clean energy side? Who wins there?
Storage developers who are pivoting from short-duration balancing to providing premium, highly reliable, longer-duration battery systems will see much stronger economics.
Right, the batteries that can actually last through a storm.
Exactly. And of course, the nuclear developers who possess credible technology and have secured those big tech anchor tenants, they now have a viable path to commercialization that didn't exist 5 years ago.
Okay, so the companies providing physical, reliable hardware are the winners. Who are the losers? Who is going under pressure as this accounting logic dies?
The primary losers will be hyperscalers who boast ambitious decarbonization narratives but lack a convincing physical strategy to procure the power they need.
All talk, no wires.
Exactly. They are facing immense operational delays and reputational damage. We are also seeing significant pressure on renewable developers who built their entire business model around that old annual REC logic.
The certificate guys.
Right. As the market demands firm, 247 power, developers selling purely intermittent wind or solar without a storage or firming strategy are finding it harder to secure premium contracts.
And what about the cities and states that are trying to lure these massive tech investments? Because everyone wants a piece of the AI boom.
Well, regions that are desperate for the tax revenue of a massive data center but simply lack the existing transmission capacity, the water resources, or the permitting efficiency to support it, they will be bypassed.
You just get skipped over entirely.
The tech companies cannot afford to wait for a region to figure out its infrastructure. It is a brutal, pragmatic sorting mechanism.
So what does this all mean? For you listening right now, the takeaway is deeply physical.
Very physical.
The next time you open up a generative AI tool, type in a prompt and watch it spit out a brilliantly complex answer in 3 seconds. I want you to picture what is happening behind the screen.
It's not magic.
No, it's not.
Mm.
Picture the gigawatts of physical power coursing through localized grids. Picture the dispatchable gas turbines spinning up to meet the sudden surge in load.
Picture the steel and the concrete.
Exactly. Picture the blueprints for new, small, modular nuclear reactors being pushed through regulatory hearings. Think about the massive, chaotic, incredibly complex grid rewiring that is happening in the physical world just to generate that digital response on your phone.
The clean power story is no longer just about building the cheapest green electrons.
It's much bigger than that now.
It is about building a power system that is robust enough, fast enough, and firm enough to actually support the next wave of human industry.
Right.
AI didn't create the need for a highly reliable grid, but it is forcing the physical limits of our infrastructure into the open much faster than anyone anticipated.
It's accelerating the technologies that actually work in the physical world. It is rescuing stalled industries like nuclear, and it is ruthlessly exposing every single place where our climate theories were elegant on paper, but incredibly fragile in practice.
And this raises an important question, something for you to consider as this transition accelerates.
What's that?
If big tech, the massive hyperscalers, essentially become the primary financiers and architects of the next generation of our power grid.
Since they're the anchor tenants now.
Right. If they are the ones funding the nuclear plants, locking down the global supply of transformers, and driving the immense demand, how will that shift the fundamental balance of power in our society?
Oh, that is a heavy thought.
Will the electrical grid of the future ultimately be designed to serve the democratic public, or will it be optimized to serve the algorithms first?
Wow. We started this deep dive looking at a sudden boom in software, but what we're actually looking at is the physical construction of a completely new world, driven by a freight train of demand that absolutely will not stop. Something for you to ponder long after this deep dive ends.